Good afternoon, everybody. Thanks for joining us for another ATR guide. So what I'm going to do today is teach you electric, how electric works on cars, how you can use a scope on cars. We're having issues today as just changing out parts that are not necessarily need to be changed out. If we can learn what the voltage should be on the part, or how the part functions, or what the part should function as, you're going to be able to fix the car quicker and easier. So if you know the voltage on the part with a scope, then you're going to know what the voltage should be on the scanner, which makes it a lot easier, so because then you can just isolate the problem. And when I mean isolate the problem, I mean we're going to take a map sensor. We have 3 wires. We're going to test the voltage to it. We're going to know what the voltage should be. If we go to the scanner side, we're going to go to the map sensor, look at the voltage on the computer, and we're going to know if the voltage is right or wrong. So we're going to take a lot of the guessing out. And what I'm going to teach you today, hopefully, is how to use the scope properly, and then different ways of using the scope to make your life easier diagnosing these difficult vehicles. So here we go. First thing we're going to do is we're going to go into the scope. Here's the scope here. So I'm going to hit the scope, and then we're just going to do lab scope. So here's our lab scope, and then we're just going to do voltage. So now we have our voltage here, and we're going to look at it. So we have different PIDs, or different traces, or here. So you have 1, 2, 3, and 4. And what the 1, 2, 3, and 4 means, you have multiple scopes. So if you wanted to check, say, a map sensor along with a cam sensor, along with the ABS sensor, or whatever voltage you want to do, you can do it with 4 different leads. So you can have 4 leads onto one sensor, 4 leads onto different sensors. A lot of times this is how I get my cam and crank correlation videos, to see if the cam and crank is out. And it makes it a lot easier. Which way is it easier, to pull the voltage and look at the voltage, or to pull the timing cover off and it still may not be bad? So this is the kind of way I do my cam and crank correlations, where the back probe is. So I am going into, actually I found this harness right here. So I'm going into the harness here, and I'm back probing an injector, and I'm back probing the cam sensor, and I'm also back probing the map sensor, because I just want you to see the map voltage compared to a signal voltage compared to an injector, and how you can tell how much the injector is working. So I'm starting the vehicle up, and we're going to go in through this scope real quick. And also we're going to use a low amp probe. Now, a low amp probe is personally my favorite tool. Now, low amp probe is personally my favorite tool, and what you do is you hook it straight to the battery. Now I have it going to the body ground, which everything goes through the ground. I like using the ground side better than the positive, because the positive will kind of split out. When you have a battery, the positive will always go to your negative, so even though it's going through the body ground, it's still going to go through your negative. So that's more of the reasons why I like to use the body ground on a low amp probe. Now, low amp probe is to draws, but it does so much more. It can tell you how many amps are being out of an injector. It can tell you how many amps are out of a fuel pump. It can tell you how many amps out of solenoids. So it's a very, very useful tool, and it's my favorite tool because it's easier just to go around the wire than it is to try to dig it and find it. So now we're going back to our scope. I'm going to zoom in this a little bit more so we can kind of see it too. Now I also have it on this. So first thing we're going to do is we're going to click on number 1. So we can see where my arrow is, and we're going to click on it. Now we can see we got a bad ground. Anytime you get a lot of distortion or anything like that, always look to your ground and then figure out a good ground. There we go. So now we got a good ground. So just remember, when you get a lot of that distortion stuff, you're going to have ground. Now see, how the injector pulse width is moving all the way around. Now the way you fix this is you set your trigger. So over here on the right hand corner you see where it says slope. Now if you click on that, you're going to get a yellow plus sign. The yellow plus sign is your trigger. Now so you can see your trigger here, and let me put the cursors on so I can show you some things just with this. So see, we have our trigger here. Now say I wanted to bring my trigger all the way to the middle so I can get a better view at it. All you do is you grab your little plus sign and you move it to the middle, and your trigger is going to follow you, your signal is going to follow you there. Now say we want to take the signal and make it wider so we can get a better measurement. You can see that we have, let's actually measure this, alright? So we're going to have this here, and we're going to put the other side, trace 2, on the other side of the injector. Now if I go to the second one, you're going to see where it says you're on the bottom hand right here, your milliseconds. So you're going to look at your milliseconds to see how far it is. So it says it's 4.56 milliseconds. But say I wanted to see if there's any kind of glitches in it or anything like that. So what you do is you just, on this you'll open it up, and then here where it says 200 milliseconds on this one, you would just click on that, and then you would say 50 milliseconds or say 20 milliseconds. And as you see, it keeps getting wider. So now we have this, and if you want to see this, now it says 0.23 milliseconds. But if we take this and move it all the way to the end, it's going to be 3.83 milliseconds. So it's more of an accurate type of milliseconds that you can look at. Accurate milliseconds that you can look at. So you're able to see the distance of the milliseconds. So if you're looking for any kind of glitches or anything like that, you just separate your milliseconds and you look at it. Now the one thing I do like about the Zeus is when you hit your stop button or your pause button, it's going to pause your signal. Now that's your signal there, it's paused. But all the way over to the right, you're going to see a little magnifying glass. Right here on the edge, you can see it coming in there. So when you click on that magnifying glass, and what it will do, it will record everything you did per that session. So here you can see that we have our injectors, but they're faster and quicker. And all we're doing is taking the magnifying and then distance our injector. So you can do this a lot. Now you can do this a lot like with pulse width. So if you can do this with pulse width, you can actually do this with your cam and crank correlation. So a lot of times I can zoom in on that cam and crank correlation to make everything work good. So it's going to work, and then you can see more in how close your timing chain is. So you got to remember that on a timing chain crank correlation, when you zoom it, or it's going to be off a little bit anyways because of the VVTs and the timing that goes through there anymore. So now if we go and then we go up to 32, because you're going to see it all the way down. Come on. You're going to see here you got different times. So say I want to do ×4. You move here, you can move your patterns. And you just take it and you move and you slide it. So now you can see this to there. So if we hit that and then say we hit number 2, it's going to get it to the next size up. And then same with 1, it'd be the original one. You also have ×2 here, or single movements, and then you also have double movement. So it just, one is making step by step and the other one is making double steps. So you can move it as quicker any way you want, but you also can slide it through this. Now I'm going to turn off number 2, and we're going to go look at what number 2. I have it on the cam sensor. So with the cam sensor, it's going to have a different square wave. So it's just going to be a regular square wave, and you'll see, and you got to look at it as when you have your metal pieces that go around and go up against the cam sensor, that is the distance that it goes by. So if you have say 1, 2, 3 quick ones and then one that's long, that's what your pattern's going to look like. So whatever's on your flywheel or whatever's on your crank sensor, those spikes is what makes the difference in length of the cam sensor or crank sensor. Number 2. Now you can see that our cam sensor is going a little bit off. So we want to over here again hit our spike. So now we set our number 2 for a trigger. Now you can see this is above the voltage. You always want to be below the voltage. And that's what's going to make it stop. Nice too is you can see that this pattern is upside down. And we need to get it to the other way. Instead of taking your negative or taking the wire and go to the other side, all you have to do where it says here, where it says invert, we're just going to click, and then now we're going to go to our positive side. But we see our X, our little plus sign, is underneath the voltage, and that's why your pattern is still not steady. So what you have to do is you just grab your little plus sign and bring it above the voltage, and then now you have a steadiness. So now if we want to change the milliseconds so we can look to see what our cam sensor pattern should be, we're just going to hit our 10 milliseconds here and then say we're going to hit 100 milliseconds. So you can see our cam sensor is 2, 3, 2. If we want to go and hit our magnifying again, and then now you can really see it. It's a 1, 2, 3, 1, 2, 3, and so on and so on. And then if you had your crank sensor here, you'll be able to see where your crank sensor mark would be along with your cam sensor. Say I want to check my injector along with my cam sensor. I would just click over here and bring your window bar up so you have your windows here, and then you just hit your number 1. Now you can see that if you wanted to change your trigger to number 1, you would just go over to where it says slope here, and you click on that slope, and then that would change your trigger to the number 1. And you can see that the voltage is down here, so we have our plus sign above that voltage, and then that's why it's steady. But also it's keeping time because we're losing the number 1 trigger, whatever injector is, and then that's keeping your cam sensor in time. So if I wanted to see more of it, I can see exactly when that injector hits to your time. So this is pretty much the basic parts of using a scope. Now say if you wanted to check the map sensor at the same time, you would just go to 3 and then turn it on. So here we got 3, and over here to the right is our voltage, and over here to our left is our milliseconds. So we have 200 milliseconds here. Here's 0, 20, 40, 60, 80, and then 200 there. If we change our milliseconds to, say, 500 milliseconds, and then you're going to see 0, 50, 100, and then 500 over at the end. So your 500 would be here. That's how you can see your pattern through your milliseconds. You can see it's at 1.4 volts. If you wanted to change your voltage to a better voltage, you would just click on your 5 volts and say 2 volts. That makes it more sensitive, and you can see here where it says 0 to 1.4 volts, and you can bring this down if you'd like. Here you just got to grab that number 3 and then slide it down. Just like here, if it's up here, arrow, and then you'd go up and down. But we need it at 5 volts. So we're going to put it at 5 volts. Now, what I want to do is I'm going to go ahead and give it some gas, and you're going to see the voltage go up and then the voltage go down. It's just regular DC voltage, so we're only really measuring the voltage side. So it's going to go up and then it's going to go down as we give it gas. I want to see what happens, so I'm going to pause it, and then I'm just going to grab this down. So you can see as the map sensor goes up and then it goes down. Thanks for watching part 1. Make sure you watch part 2. It's going to be a lot on low amp probes. And I do love the low amp probe.